In this problem, we want to determine open intervals which a graph of the function is concave upward or concave downward. So we got f of x is equal to 2x over x squared plus 1. Now, our first step is to find our second derivative. We're going to have to use the quotient rule here. Top part will be p, bottom part will be q. We need p prime and q prime. P prime, the derivative of 2x is 2. For q prime, the derivative of x squared plus 1 is 2x. Now our formula is p prime q minus p q prime over q squared. So for our first derivative, p prime was 2 times q, which is x squared plus 1, minus p, which is 2x, times q prime, which is 2x. That's weird. Let me double check that. I guess so. Over q squared. So we got x squared plus 1 squared. Well, get rid of the parentheses up on top here. 2 times x squared is 2x squared. 2 times 1 is 2. Minus 2 times 2 gives us 4, and x times x is x squared. Over x squared plus 1 squared. Combine together like terms. We've got 2x squared minus 4x squared. That gives us negative 2x squared plus 2 over x squared plus 1 to the second power. And that's our first derivative. That's f prime. Well, we need our second derivative. So we're going to use the quotient rule again. Top parts can be p, the bottom parts can be q. Now our p prime, the derivative of the top, that gives us negative 4x. The 2 drops away. Now q prime, this is the chain rule, specifically a general power rule. We've got parentheses to a power. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside the parentheses. So we got 2 times x squared plus 1 times the derivative of x squared plus 1 is 2x. 2 times 2 gives us 4x, x squared plus 1. So our formula is p prime q minus p q prime all over q squared. So for our second derivative, p prime was p prime negative 4x times q, which is x squared plus 1 squared, minus p, which is all this, negative 2x squared plus 2, times q prime, which is this, so times 4x x squared plus 1, all over q squared. And q was x squared plus 1 to the second power, and then we square that. Now up on top, this is considered one grouping, and this is considered one grouping. Why do I say that? Everything's multiplication. Negative 4 times x squared plus 1 squared. Over here we got this parentheses times 4 times x squared plus 1. Now I notice that they have something in common, and I notice they both have a 4x and an x squared plus 1. And actually I can bring out a negative too. So I'll bring out a negative 4x x squared plus 1. Well, that negative 4 and that x are gone. One of these x squared plus 1s is gone, so we're left with a single x squared plus 1 out of the first group. This 4x is gone, this x squared plus 1 is gone, and one of these negative is gone. So we're left with a minus. Actually, this negative is gone, so we're left with what's inside the parentheses here. So we got negative 2x squared plus 2. All over x squared plus 1. When you raise one exponent to another exponent, you multiply them together, so 2 times 2 gives us 4. Now let me double check myself there. Yeah, that looks good. Okay. Like my music to pass the time. Okay, enough of that. Negative 4x times x squared plus 1. We'll simplify what's inside the bracket. X squared minus 2x squared gives us negative 1x squared, or negative x squared. 1 plus 2 gives us 3. All over x squared plus 1 to the 4th power. Now notice we have an x squared plus 1 here, and we have an x squared plus 1 to the 4th power here, so we got 4 of them. So this one right here is going to cancel with one of these. So that's going to leave us negative 4x times negative x squared plus 3 all over x squared plus 1 to the 3rd power. And that's our second derivative. Let me find a pen here and paper. Okay. Negative 4x, negative x squared plus 3 all over x squared plus 1 to the 3rd. Okay, I'm going to continue the problem up here. So we just said the second derivative is equal to negative 4x, then negative x squared plus 3 over x squared plus 1 to the 3rd power. Okay, now I want to find our critical values, so we're going to set top part equal to 0 and bottom part equal to 0. So I'm going to set negative 4x times negative x squared plus 3 equal to 0, and I'll set x squared plus 1 to the 3rd power is equal to 0. Now over here this is already factored, so I'll set each factor equal to 0. I'll set negative 4x is equal to 0, and negative x squared plus 3 is equal to 0. Now negative 4x is equal to 0, I'll divide both sides by negative 4. And we get x is equal to 0. Now here I'll take negative x squared to the right side, and we get 3 is equal to a positive x squared. Now square root property. If you got something squared equal to the other side, you drop your squared and put a plus or minus square root on the other side. So we get x is equal to plus or minus square root of 3. Now here, if you have parentheses to a power equal to 0, you can drop the power. So this becomes x squared plus 1 is equal to 0. Take the 1 over, it becomes a negative 1. And the square root property says you drop your squared and you put a plus or minus square root on the other side. But there's a problem here. A negative inside of a square root gives us an I. We don't want any i's. So these are our 2 or 3 critical values. Okay, so I got x is equal to negative square root of 3, x is equal to 0, and x is equal to square root of 3. Now we'll pick test cases. Something between, and clear over here is negative infinity, clear over here is positive infinity. Something between negative infinity and negative square root of 3. I don't know what negative square root of 3 is, negative 1 point something. So maybe negative 4. Make sure I'm on that side. I'm going to choose something between negative square root of 3 and 0, like negative 1. Something between 0 and square root of 3, like 1. And something greater than square root of 3, like 4 or 5 or something like that. Now we want to plug these into our second derivative, which is right up here. Now to plug this in your calculator, the key is whenever you're working with a fraction, if you got more than a single variable, single number on top or bottom, you have to put parentheses on it. So as we plug this in, we'll put parentheses on top, parentheses on the bottom. You actually don't need them around the bottom. But just to be on the safe side, it's always a good idea to do that. And when I say don't need them around the bottom, I mean specifically for this problem. And I'm not even sure, I don't even think you need them around the top, as weird as that seems. But again, it's good consistency to always do that. Okay, so I'm pressing my y equals, press clear. Beginning parentheses on top, that's this one right here, negative 4x, negative 4x. Notice it's not the minus, it's the negative on the bottom row. And beginning parentheses, then negative x squared plus 3 closing parentheses, that's this one right here, and then another closing parentheses. Divided by, parentheses are on the bottom. Then we got another beginning parentheses, x squared plus 1, close parentheses, caret 3. Now you want to make sure if you got one of the newer TID4s, you press your right arrow key to get out of exponent at this point. But I'll do another closing parentheses. Now I want to make sure that my table is set up correctly, so I do second window. Now you see where it says independent? That should say ask. If it doesn't say ask, down arrow to that line, right arrow, put your flashing cursor on the ask and press enter. And then we'll go to second graph to go in the table. Now press delete a few times, get rid of those. And we'll plug in our test cases. So I'll plug in -4, enter, -1, enter, 1, enter, 4, enter. Okay, -4. That gave us a negative value, which means this is concave down. Now -1. That gave us a positive 1, which means this is concave up. 1 gave us a negative value, which means this is concave down. And 4 gave us a positive value, which means this is concave up. So our answer, based upon that, is it's concave down from -infinity to negative square root of 3. And then it's concave up from negative square root of 3 to 0. And then it's concave down from 0 to square root of 3. And then it's concave up from square root of 3 to positive infinity. Now sometimes you can look at your original graph and actually see this concavity change. Sometimes you can't. Let's just out of curiosity, let's graph this original problem. Remember, if you have a fraction, the key is you put parentheses around top, parentheses around the bottom. So put parentheses around top, parentheses around the bottom. I'm going to plug it in. So I'm going to press y equals, clear. Now do beginning parentheses, 2x, closing parentheses, divided by, beginning parentheses, x squared plus 1, closing parentheses. And now let me press graph. And I'm going to zoom in. So let me press zoom. And I'm going to choose Z box, the first one. So press enter on that. I'm going to do my up arrow, my left arrow. And you should see a little flashing plus appear on your screen. I want to go to about right there. Press enter one time, then do a down arrow and right arrow. And what you should see is a box being drawn. So we're going to draw a box around what we want to zoom in on. This is kind of a real precise way so you can get exactly what you want. That's probably good there. Once you get it to where you want, then press enter one time. And you'll see it. Square root of 3. That's like 1 point something. I wish I had my calculator handy. So negative 1 point something is about right there. Yeah, it looks like it's concave down going up there, and then changes to concave up. Concave up, and then concave down. So that does seem to fit the pattern that we wrote down here. But those are our answers. Oh, and one last thing. To set your calculator back to where it was, you press zoom and then choose 6. That sets back to Z standard. And those are our answers.